Hello friends, welcome to the Power Pack session of Open Channel Flow. So in short form we call as OCF. So before starting, I will just give you the rough idea what we are going to do in this Power Pack question session. In this session we will discuss some 7 questions based on Open Channel Flow concept. In such a way, I have selected that question in such a way that all the parts, all the small or big part or conceptual part in Open Channel Flow will be get discussed in this session. The agenda of this session is such a way, in such a way that you will get to know even a small part of Open Channel Flow. And the second agenda is this: based on this 7 question, you can start preparing or you can do the revision part of your GATE preparation for 2019. Okay, so before starting this session, I just want to give a small introduction why OCF is important in civil engineering. So Open Channel Flow is a chapter or a unit inside the fluid mechanics part, and every year if you see the stat part, every year you will find 3 to 5 marks question from this particular area, and this makes this topic very important. So if you are having very less time as you have now, so if you have very less time and you have to excel in the fluid mechanics part, so start your preparation with OCF, and I hope that this 7 question will help you in preparation of GATE exam. So after this, I just want to start with the first question. So the question will be shown in board. Please look in there. So first question is: a stationary hydraulic jump occurs in a rectangular channel with the initial and sequent depths being equal to 0.3 meter and 1.5 meter respectively. And they are asking the discharge per unit width of the channel is option R 1.99 meter cube per second per meter. B option is 1.88 meter cube per second per meter. C option 1.77 meter cube per second per meter. D option 1.66 meter cube per second per meter. And next thing they are asking is energy loss. So option A is 0.64 meter, option B is 1.26 meter, option C is 0.96 meter, option D is 0.88 meter. So first of all, I just want to tell you that this question is related to hydraulic jump part, and hydraulic jump comes under unsteady, rapidly varied flow. So in that particulars we have discussed in our lecture session that in hydraulic jump flow, if you are in rectangular channel, so definitely what will happen, some 5 or 6 formula you will get especially for rectangular section. So before starting this question, I just want to give the given data what you have in this question. So given data is like initial depth, that is Y1, initial depth, or you can say it's a pre-jump depth. So that is given as 0.3 meter. Next thing is given is sequent depth, or we can say it's a post-jump depth. So that is Y2. That is given as 1.5 meter. And the first thing they are asking is a discharge per unit width, that is Q. Okay, and the second part we will discuss later. So discharge per unit width, first thing they are asking. So before starting, I just want to give a small introduction about what is this initial depth and what is this sequent depth. So initial and sequent depth are the depth which occur in a hydraulic jump, and in that depth your specific force will be same. What is the concept? A specific force concept is related to the momentum concept. It means for both the depth, your specific force will be same. So before starting this question, I will just tell you to recollect all the data, all the formulas you have in a rectangular section of hydraulic jump. So if a hydraulic jump is occurring in a rectangular section, so what are the formulas are there? So one formula, as you remember, is 2q square. This q is small q, equal to y1 y2 y1 plus y2, where y1 is initial depth, y2 is sequent depth, q is discharge per unit width, and g is acceleration due to gravity. So this is the formula, I think one of the important formula in hydraulic jump for a rectangular section. This formula is specifically for rectangular section, and in this question it is given it's a rectangular channel, so we can use this formula to find out q, and that only we have to find out. So if you put this value, so 2 into q square upon g value is 9.81, y1 value is 0.3, y2 is 1.5, sorry. So the value which we will get, that is q. After solving this, what you will get? Q equal to root under 9.81 into 0.3 into 1.5 into 1.8 upon 2. So if you calculate this part, what value you will get? The value which you will get will be 1.99 meter cube per second per meter. Why I have written this meter cube per second per meter? Because Q is discharge per unit width. So discharge unit is meter cube per second and the unit of width is meter. So this is the final answer for first part. This is the final answer for first part. Now I am running this part, and second part in this question they are asking what will be the energy loss. What will be the energy loss? Definitely if a hydraulic jump is happening, so what you will find, some energy loss will be there, definitely. And if energy loss will be, so what will be the energy loss in this problem? So they are giving 4 options. Option A is 0.64, option B is 1.26, option C is 0.96, or option D is, the last option is 0.88. So before starting the second part, I just want to tell you that energy loss is because of hydraulic jump. So energy loss, directly we'll go to the formula part. So that part we are denoting with delta E. This energy loss will be delta E, and this will be equal to y2 minus y1 to the power cube upon 4y1 y2. So these formula for first and this formula is for second. This formula you have to not mug up, but you have to memorize. And how you will get this formula in exam? If you practice too much, in the sense if you practice 4 or 5 questions based on this formula, you will also get to know how it comes. So delta E equal to y2 minus y1 to the power q upon 4y1 y2. So I am rubbing this part. I hope you got this thing, first part. So delta E will be y2 is 1.5 minus 0.5, that is 0.3, that is your y1 power q upon 4 into 1.5 into 0.3. And if you solve this, what value you will get? You will get 0.96 meter. And if you check the option, option C will be your correct answer. Option C is the correct answer. Option C is correct answer. So you understood how you will find energy loss when a hydraulic jump is occurring in a rectangular section. So this is the formula to find out the energy loss, and this is the formula to find out the discharge per unit width. This both formula is especially for rectangular section. So please don't be confused. This formula is especially particularly made for rectangular section. Okay. So this is our first question. In first question, the first option A will be for A part. Answer will be what? Q will be something 1.99 meter cube per second per meter, and that delta E, that is the energy loss, will be 0.96 meter. So now we will go to the next question, that is second number question. So second number question is like a 2 meter wide rectangular section, a 2 meter wide rectangular section flowing at its normal depth of 1.2 meter carries a discharge of 6 meter cube per second. If a section, the depth of flow is 1.10 meter, the water surface at that location is a part of gradually varied flow of type. So they are telling it's a gradually varied flow, but which type, that you have to find. Option A is S2, option B is M2, option C is M3, and option D is S3. So this question is very important because this question is related to the gradually varied flow, and this question is little bit related to the classification of slope. So to solve this question, you have to know the concept of how a flow or a section is classified as steep or mild. So what are the condition and how you will go, that we will look in this question. So first in this question, what are the given data we have? Question number second. And this is the practical approach. If you are solving any question, first write the given data. That will it's like make you easy to solve that question. So whenever you are solving any question, whether in exam or whether in a practice paper or whether in a mock test, first write the given data. That will help you, and I am telling this by practice, because if you write the data, all the given data, you will understand how to find out the answer and what quantity we have to find out. So you can make the relationship between them. So given data writing is a very much important part. So given data is, it's a rectangular section which is 2 meter wide. Normal depth, that is Yn, is 1.2 meter. Discharge, that is capital Q, is 6 meter cube per second. And at a particular section, your depth of flow is, that is Y1 I am taking, is 1.1 meter. And in this they are asking, this section is mild slope, steep slope, or whether a different slope. So first of all, to understand whether it is a mild or a steep, you have to know two data. The first one is Y1, that is normal depth, and second is YC. So Yn and Yc are normal depth and critical depth, and based on these you can compare whether that slope is steep or mild. So Yn is given in this question, so first we have to find out that is Yc. First we have to find out that is Yc. And in this question it is given, it's a rectangular section, so you know Yc for rectangular section will be equal to Q squared upon G to the power 1 by 3. And this small q is nothing but discharge per unit width. So discharge is given in this question, that is 6 upon width is also given, that is 2. So you will get 3 meter cube per second per meter. That is small q. So now this value will put in Yc. So Yc is equal to 3 squared upon 9.81 to the power 1 by 3. So what is the value you will get? Yc. Yc you will get as, after calculation you will get Yc equal to 0.97 meter. 0.97 meter. So now just look in this part. We have Yn equal to 1.2 meter, Yc equal to 0.97 and Y1 equal to 1.1 meter. So as you know that if Yn is greater than Yc. If Yn is greater than Yc, it means it's a mild slope. This indicates mild slope. This indicates mild slope. Now, in this option given are, what are the option which is given to this question? Option which is given is whether it is a S2, M2 or M3 or S3. So in this they are not asking whether it is a mild or steep. They are asking specifically whether it is a M2 or M3 inside mild slope. So inside mild slope, it means you have to use the particular depth, that is Y1. So you have to compare now these all three value. So if you look at in this part, what we have the data. So Yn is greater than Y1 and Y1 is greater than Yc. Yn is greater than Y1 and Y1 is greater than Yc. So if you look this, the water surface slope will exist between CDL line and NDL line. CDL line and NDL line. So it means this indicates water surface slope will occur between CDL, that is critical depth line, and NDL, that is normal depth line, which means it is M2 slope. This will show M2 slope or M2 water surface profile slope. So this is M2. So if you look in this option, what will be your option is, the correct option will be B. The correct option will be B. So I hope you understand this part. So this question is specifically about gradually varied flow. So how it is happening, and if you have to classify, so first of all you have to find out the critical value, in the sense Yc, and then you have to find out the Yn. And based on these two values, you will decide whether that slope is mild or steep or horizontal or critical or adverse. These are the types of slope you have in gradually varied flow. And after that, to come to the specific part, what you have to do, you have to take a depth at a particular section and you have to compare that depth with other like Yc and Yn. And how that change is, based on that you can tell whether it is a M1, whether it is a M2, whether it is a M3. So I hope you understand this question. So coming to the next part, that is the third question we have. For a flow in a rectangular channel of width 4 meter and depth of flow 2 meter, Darcy-Weisbach factor F is estimated to be 0.01, full stop. Estimate the value of Chase's and Manning's constant. And the option is A, 58.58. In this option, first part I am telling about Chase's and second part I am telling about Manning's. So don't be confused in that part. A option is 58.58, 0.0016. B 58.58, 0.0012. C 88.58, 0.0112. D 66.64, 0.0112. So this is the question. So before starting the question, just write the first part. As I told that you have to write the given data. It will really help you. It's my suggestion for all of you that please write given data in a separate page or separate or fresh page. That will help you. It's my suggestion to all of you. So question number 3 we are discussing. So what are the things are given? That is B equal to 4 meter. It's a rectangular section. Darcy-Weisbach factor, that is F, is given as 0.01. Depth, that is Y I am taking, that is 2 meter. And they are telling you to calculate the value of or find the value of Chase's and Manning's coefficient. Chase's and Manning's coefficient. Chase's means we are denoting with C and Manning's we are denoting with small n. Okay. So these values we have to find out. So again, just look it in the rectangular section part. You know this Chase's constant that we are denoting with C is equal to root under 8 into G upon F. This Chase's constant is actually equal to root under 8 into G into F. This constant part, what Chase's take, this constant part they made as a all the 8 are constant, G is constant for Earth's surface, F is constant for a particular pipe or particular channel. So C will be the constant part, that is Chase's constant. So if you have to find C value, so that will be 8 into G value, you know, G is acceleration due to gravity, so it will be equal to 9.81 upon F value, it is given in this part, so that is 0.01, and if you calculate this part, what value you will get? You will get C equal to 88.58. I am writing here. C equal to 88.58, and as it is a constant, it will not have any unit. It will be a dimensionless quantity. So that is your C. Now second part. Second part of this question is to find out the Manning's coefficient. So you know that Chase's constant, Chase's formula and Manning's formula for velocity. So to make a relation between Chase's and Manning's, what we will do, we will solve Chase's and Manning's formula at a time. It means what you will do, you will take Chase's velocity and plus equal, that will be equal to Manning's velocity. So how I am doing, just look into the board. So velocity will be equal to, if you are taking Chase's, C root under R into S, where R is a hydraulic radius, S is a bottom slope. And for if you take a Manning's formula, that will be V is equal to 1 by N R to the power 2 by 3 S to the power 1 by 2. What actually is V equal to 1 by N R to the power 2 by 3 S to the power 1 by 2. S is same slope, R is hydraulic radius, N is Manning's coefficient, or we can say it's roughness coefficient. Okay. So now we will equate this two equation. So it will be like C root under RS, that will be equal to 1 by N R to the power 2 by 3 and S to the power 1 by 2. So you can see root under S and root under S is on both sides, left and right. So we can cancel that part. So finally if you calculate, you will find C equal to 1 by N R to the power 1 by 6. If you calculate this part, nothing. Just you have to cancel out the root under S part, and in right you have R to the power 2 by 3 and in left you have R to the power 1 by 2. So just transfer that R in a right side part. That's it. So you will get this equation C equal to 1 by N, and this is the relation between Chase's constant and Manning's constant. So now in this question you got the value for C, and that value you have to put in this equation, that is 88.58 will be equal to 1 by N R. Now R is the part that you have to find out. So R is basically what? It's a hydraulic radius. So R is hydraulic radius means what? R will be equal to A upon P. So to find out area or perimeter of a section, you have to know two data. What are those two data? That is width and depth of flow. So width is 4 meter given and depth of flow is also given. So you can put directly. So R will be equal to A by P to the power 1 by 6. So 88.58 will be equal to 1 by N. A will be B into Y. B into Y. So B is 4 meter. B is 4 meter and Y is 2 meter. Upon perimeter will be what? B plus 2Y. Perimeter for a rectangular section. As it is mentioned, it is a rectangular section, so perimeter will be b plus 2y. So b is 4 plus 2 into y, that is 2. So finally what value you will get? If you calculate this part, the n value which you will get is nothing but 0.0112. And as you know that n is a constant, so you will not have any dimension for n. So you understand how we calculated C value, and based on this C value, how we calculated Manning's constant value. And these are the parameters that we have to find out in this question. So as you get to know, C will be 88.58, that is your first answer, and this is your second answer. So please look it in the option part that you have. If you check C option, in that it is given that C equal to 88.58, that is Chase's constant, and Manning's constant is given as 0.0112. 0.0112. So that is given in your question. So you can look at that. So based on this, you can find out that option C is the correct for third question. Option C is the correct for third question. Coming to the next question, before going to the next question, I just want to tell you that velocity formula in open channel flow is very much important. Especially, you have to understand how a Manning's formula changes or how it is related with the changes, and why we have taken Manning's as important. This is a small reason which I want to give to you. Manning's formula is generally preferred over Chase's formula. This is the only reason we have is Manning's formula is experimentally determined. So if you find out a formula based on experimental value, what it will give, it will show the experimental, in the sense, practical part. So if any formula is showing the practical part, it means it is taking the practical parameter, practical error also, that is also included. So it will give more realistic value. So that is the reason Manning's formula is generally more preferred over Chase's formula. So you get to know how we can connect these two formula, how that constant are connected. So you also get to know that part. So now we will go to the fourth question that is on your board. That fourth question is, a wide rectangular channel has a longitudinal slope. A wide rectangular channel has a longitudinal slope of 0.0003, and its Manning's roughness has been assessed as 0.02. Full stop. Calculate the normal depth in this channel when the channel conveys a discharge intensity of 2.3 meter cube per second per meter. And the option which is given to you is 1.4 meter, that is A option. Option B is 1.6 meter, and option C is 1.3 meter. And last option, that is option D, that is 1.8 meter. So first, as I told you to read this question properly, because sometime what you will do some mistake in question reading part only. So that is the part, the first part you have to understand, that is writing given data. That is the most important part in solving any question. So given data is, this is all about question number 4. Given data for this question is like, first it is a wide rectangular channel. So write this part, wide rectangular channel you have. Wide rectangular channel. Longitudinal slope is given, that is S0 is given 0.0003. So please don't do mistake in writing 20 or 30. It is 30 after 3 is there, next point. After that 3 is there. So Manning's roughness coefficient, that is something but N, that is 0.02. And the last part which is given is discharge intensity. Now the question comes, in discharge intensity, what you have to do, recheck the unit part. That is the most important part. So if you see the question in this shown you to, discharge intensity is, that is Q equal to 2.3 meter cube per second per meter. So you can understand that part. So how it is given this unit? It's a meter cube per second, that will be discharge, and per meter, that will be your discharge intensity. It means discharge per unit width. So that's why I have written this notation of your symbol of this part is small q. That is showing discharge per unit width. I hope you understand the given data part. Now look at in this question, it is given you to find out Yn. What is Yn? Yn is normal depth. So Yn you have to find out. So if you look at this data, they have given N, Q, S naught. So it's like in given data itself, they have given you a hint. If N is given, definitely you are going to do something with the Manning's equation. Manning's equation is for what? Velocity. And to use that Manning's equation, first you have to write what? What is the Manning's equation? So Manning's equation for velocity, that is V equal to 1 by N R to the power 2 by 3 S to the power 1 by 2. This is, you know about Manning's equation. So V is basically something. In place of V, what I can write out? V is Q upon B into Y. Q upon area I can write. N will be N only. R in place of R. So now look at in this question. It is given it's a wide rectangular channel. What is the meaning of wide rectangular channel? Wide rectangular channel meaning is the width of that section. Is very much large as compared to the depth. Width of the section is very much large as compared to the depth. So how you will find R for that particular case? Just look at in the right side of the board. How I am going to solve that part. So R equal to what you know, that is A by P. So A is for rectangular section, it will be B into Y upon perimeter, that is B plus 2Y. So if you look at this part, so this is your B, this is your Y. So now for a wide rectangular channel, B is, that is width is very much greater than Y. B is very much greater than Y. So if V is very much greater than Y, then this part we can exclude. Because B is very much, it's like B is 1000 and Y is 1 meter. So 2 into Y, that is 2 in 1000, it's not at all matter. So that part we can remove or we can exclude. Only for this special case. This case is wide rectangular channel case. So what this equation will become? R equal to B into Y upon B only. And finally you will get R equal to Y. I hope you understand how this R equal to Y comes. So that part we will directly going to put here. S to the power 1 by 2. So now in this question, if you look at this part, Q upon B, this is something but small q. This is something but small q. So Q is given as 2.3 upon Y 1 by N. N is given as 0.02. R equal to Y. Y, that is, we have to find out the Y to the power 2 by 3. S is given as 0.0003 to the power 1 by 2. And if you calculate this, you will get Y, that is Yn, you can say Y is something but 1.79 meter. 1.79 meter, or approximately you can tell it will be equal to 1.8 meter. Approximately you can tell it's a 1.8 meter. So if you look at in this question or option A is 1.4, that is wrong. Option B is 1.6 meter, that also wrong. Option C is 1.3 meter, that also wrong. And last option is option D, that is 1.8 meter. So option D is the correct part. So option D is the correct answer. I hope you understand how we find out normal depth, that is y, with the help of Manning's equation. I hope you understand this part. And best part of this question is, or you have to understand what learning you have got from this question is, whenever you have to find out the normal depth, please use Manning's equation. Only when n value and s naught value is not given, then only search for other option. Otherwise, if these values are given in this question and they told you to find out normal depth, please go to this procedure and use Manning's equation, that will give you the normal depth. I hope you understand this part. Coming to the next question, that is in your board. So this question is related to a small quantity, which is maybe it will be new for you, or may already you know about this. That is section factor. What is that? I will tell you later. Before that, I will just read the question that is on your board. In a triangular open channel, normal depth is 2.8 meter with side slopes of 2h ratio 1v. It means 2 meter in horizontal and 1 meter in vertical. They try to give you slope of that section. Then they are asking for what is the section factor. Options are A equal to 18.55, B is 17.0, C is 15.68 and D is 16.75. D is 16.75. So this is a little bit new because you don't know what is section factor. So don't be in problem. I will tell you what section factor means. It's not a tough question, but it's a new question for you. So question number 5, as I told before, go through a solution part. First write what are the given data you have in this question. So first they are telling it's a triangular open channel. So make a triangular open channel. This means I am showing the water surface. This is y. And they have given you 2h1v. So I am showing that part. That is 2h1v. Okay. So 2h1v, they want to give you the slope of that side of that triangular section. So they want to give that slope. And next is given as y, that is normal depth is given as y and equal to 2.8 meter. 2.8 meter. So these are the all given data you have. So now they are asking the question, that is section factor. So before starting this solution part, I will tell you what section factor is. So section factor is nothing but a cube upon t to the power 1 by 2. A cube upon t to the power 1 by 2. Where a is the area and t is the top width. Where a is the area, t is the top width. So two things you have to find out to calculate the value of section factor. To find out the area of a triangular section, what you will do? You have y, you have this value, no, this value you have to find out. And this value is exactly equal to the top width. So look at the slope, what it means. They are telling if you are going 1 meter vertical, you have to go 2 meter horizontal. So in this question it is given 2.8 meter vertical. That that normal depth of triangular section is 2.8 meter. So definitely what you have to go for one section. So if it is a 2.8 meter, this will be something 2 into 2.8. And this side also it will be 2 into 2.8. Okay, I hope you understand this part. So what I am telling, I am to find out the t value. If the vertical depth, that is y, is 1 meter, then horizontal will be 2 meter. So now in this question it is given yn is 2.8 meter. So definitely this horizontal part will be 2 into 2.8 meter, and that will be in both sides. So total width will be 2 into So total width what you will get, t will be equal to 11.8 not 11.2 you will get. So one value you get to know what that is t. Now coming to the area. So area of a triangular section will be what? Half into b into h. So half into b into h. H is nothing but the depth of the triangular section, that is yn. It is given in this question, that is yn is equal to 2.8 meter. So y 1 by 2, 2.8, that is h I am writing. Now b is something but this part. This is the total b. This is the h. This is the b. So this h is given to you, that is 2.8 meter, and this you already calculated, that is top width, that is equal to 11.2 meter. So final value what you will get, area equal to, if you find out, that will be equal to 15.68 meter square. That will be equal to 15.68 meter square. Half into this depth. So area you also got, t you also got. After that, the value which we have to find out, that is section factor. Now just substitution is remaining. So a is something, as you know, that is 15.68 to the power cube upon t is nothing but 11.2 and whole to the power 1 by 2. So if you calculate, the value which you will get is 18.55. This is your nothing but the section factor value. (18.55). And if you look at in the option part, A option will be correct option. A is the correct option. A is the correct option. So the best part of this question which you have to remember is, that this question gave you a new concept that is known as section factor. And that is important for you. I will tell you how it is important for you. Because this part is not very much asked in previous gate year. So if some part, especially for OCF,